All right, we're going to continue our learning with adding and subtracting rational expressions. We're going to take it up a notch today, but we'll start with a warm-up problem that's similar to the last lesson. Just because I want to make sure I don't forget, I want to highlight right away that that's a subtraction problem because that's going to change some signs in my second fraction later. So just so I don't forget, subtraction. All right, I need to come up with a common denominator first. Now, there's nothing that I can multiply x plus 1 by to get x plus 2, or vice versa. So the only way I'm going to get a common denominator is to multiply each fraction by the other one's denominator. I'm going to put everything in parentheses right away. So I'm going to multiply the first fraction, top and bottom, by the second fraction's denominator, which is x plus 2. And I'm going to multiply the second fraction, top and bottom, by the first fraction's denominator, which is x plus 1. It's totally fine to just leave the denominator in factored form, but in the numerator, I do want you to distribute. So I've got 3x plus 6 over x plus 2 times x plus 1 minus 5x plus 5 over x plus 2 times x plus 1. Now, when I subtract, I need to make sure I subtract both things in the numerator. So I'm going to have 3x plus 6 minus 5x minus 5. And when I add and subtract, once I have a common denominator, I just keep that common denominator the same. Combine like terms, 3x minus 5x is negative 2x, and 6 minus 5 is positive 1. And again, you can FOIL the denominator if you want, but you don't have to. It's not going to make the answer any more simple. The reason why we distribute in the numerator is because we will be able to combine like terms, and the answer will turn out simpler. In the denominator, if we FOIL that, it's really not going to look much better. So there's not really a reason to do so. Okay, now let's take it up a notch. Okay, a lot more going on here. When we do a problem like this, if you see x squareds again, just like when we were multiplying and dividing, you're going to want to factor. And you really only need to factor the denominators because our goal is going to be to find a common denominator, and they might already have some things in common. So the only thing here that I really see that I want to factor is this 2x squared minus x minus 3. And it's a trinomial, 3 terms, so I'm going to use the AC method. So a times c, 2 times negative 3 is negative 6. And I want to multiply to get negative 6, so negative 1 times 6, 1 times negative 6, negative 2 times 3, 2 times negative 3. I want to pick the pair that's going to add up to this negative 1x. So it's got to be 2 and negative 3. So I'm going to rewrite this as 2x squared plus 2x minus 3x minus 3 and factor by grouping. I can divide the first 2 terms by 2x. I'll leave it with x plus 1. So I'll have to divide the last 2 terms by negative 3 to get x plus 1. I've got 2x minus 3 times x plus 1. So I'm going to rewrite my problem now. I've got x minus 2 times x plus 1, and add some parentheses, plus 3 minus 12x over 2x minus 3 times x plus 1. They already have something in common. They both already have x plus 1. The first fraction is just missing the 2x minus 3, and it's being multiplied, so I can multiply by it on the top and bottom. Okay. Now they have the same common denominator. Again, we can leave the denominator in factored form because foiling it is not really going to make this any simpler. If you really want to FOIL the denominator, you can. It's not a big deal if you do. The numerators, though, we do want to FOIL because when we add, we're going to have some like terms we can combine. So this is going to give me 2x squared minus 4x minus 3x plus 6, and then I'm also adding 3 minus 12x. So let's combine all of my like terms. Got 2x squared. That's going to give me minus 7x, and then I'm adding a negative 12x, so that'd be minus 19x. And then I've got a 6 plus 3 is 9, and then my common denominator, which again, you can FOIL if you want, but the only reason why we FOILed on the top was so we could combine those like terms. On the bottom, we're not adding or subtracting anything to combine like terms, so we don't need to. Let's do a subtraction one. All right, I see both of the denominators are things that I could factor, and lucky for me, the a is 1 in both of them, so that makes it a little bit easier to factor. You can do the whole AC method, but if you can do it without, save you some time. Got to multiply to negative 6, so it's got to be positive and negative. Add to negative 3, or negative 1, sorry, so it's got to be positive 2 and negative 3. And this one needs to multiply to a negative 3, so it's got to be positive and negative, and add to negative 2. It's got to be 1 and negative 3. So I've got my new equation now, 5x plus 1 over x plus 1 times x minus 3 minus, we'll deal with that later, 5x minus 3 over x plus 2 times x minus 3. Okay, so they do already have one thing in common. They already both have x minus 3. But the first fraction also has an x plus 1, and the second fraction also has an x plus 2. They're both going to have all three. So the x minus 3s were good. We don't have to multiply by those. They both already have it. But this first fraction is missing the x plus 2 that the second fraction has. And the second fraction is missing the x plus 1 that the first fraction has. And now they have the same denominator. Yes, they're in a different order. Order of multiplication doesn't matter. 3 times 2 is 6, 2 times 3 is 6, so that's fine. We can leave the denominator in factored form. I don't want to distribute all of that. There's 3 things in the denominator. Now that's going to take forever, and it's not going to end up looking any better, so there's no point. But in the numerator, we do want to FOIL so that when we subtract, we can combine our like terms. So that's going to give me 5x squared plus x plus 10x, so that's 11x plus 2. And here I'm going to have 5x squared plus 5x minus 3x, so that's 2x minus 3. And 5x squared plus 11x plus 2. I'm going to subtract all of these items. So I'm going to subtract 5x squared, and I'm going to subtract 2x, and I'm going to subtract negative 3, which becomes a plus 3. And I'm going to leave my denominator alone. 5x squared minus 5x squared, those cancel. 11x minus 2x is 9x, and 2 plus 3 is 5 over my denominator. Again, the order of these 3 factors does not matter. It was definitely worth it to distribute in the numerator because look at how much simpler it got. The denominator we're going to leave alone.